Good evening, everyone. On behalf of our team, a warm welcome to Prototype Workshop 2. We are excited to have you with us as we delve into the vital theme of how to use AI agents at scale. This session is designed to bridge the gap between theory and practice, offering you insights that are both actionable and relevant to real world applications. Guiding you through this session today is Amsana Sandalkumar, and it is an absolute pleasure to be part of this learning experience with all of you. We are thrilled to welcome Mr. Nadheesh Jihan, Technical Lead AI at WSO2, as the speaker for Prototype Workshop 2. With extensive experience at the forefront of AI innovation, Mr. Jihan will be leading us through today's topic, how to use AI agent at scale. In this session, he will share insights on designing and deploying AI-powered solutions that are not intelligent and efficient, but also scalable and future-ready. If you have any questions or inquiries during the session, feel free to submit them via Slido. You can either scan the QR code displayed on screen or click the link shared in the Zoom chat box. With that, please join me in welcoming Mr. Nadheesh Jihan warmly as we begin the session.
Hello, good evening, everybody. So I think you can see my screen, right? So yeah, today we are going to have a session on integrating AI into scalable systems. Or I would like to say it as building a scalable AI application. So before moving forward, there are a couple of things that I want to clarify here. Okay. So one thing when we say AI can be anything that simulate human intelligence, like it can be a machine learning, deep learning, or even some rule-based system. But in this scope, we are trying to consider the generative AI applications because that's the current most hot thing, right? And this is where we use AI. This is a subset of AI, right? So this is where we use AI to create or generate new content. So this can be text, images, music, audio. This can be any content, but it's basically focused on generating the content. Another term I want to introduce is the large language models. I know like most of you have heard about this and most of you are aware of it, but I want to clarify, right? When we say AI, we are going to focus on these kind of generative AI models. Yeah. So when it comes to generative AI, what is the main challenge right now? So the key challenge we see right now is the hallucination. And this can be in different ways. One way is when we ask a question, it will answer us with a incorrect answer that is factually incorrect. That means the truthfulness of that answer is incorrect because of the factuality. So, for example, if we ask who is the president of USA, it will answer saying Joe Biden because it's not up to date yet. So, and as I said already, so the main reason is the knowledge limitations. When I mean data limitations that we have when we are training, we will use a limited data set, right? So the model will know only what we have used to train it. And the second thing is the reasoning gap, because LLMs or these Gen AI models are not actually generate. So logical reasoners, they are actually generators. What they are good at is looking at a set of a sequence and then try to predict what could be the next token or the next word, something like that. So because of that, inherently they are not good logical reasoners. So then this is again another reason for having hallucinations. And first thing I want to discuss is how we can scale in terms of the accuracy and the reliability of the generative AI model. Because without that, even if we scale the performance, that would not help us, right? Okay. Yeah. So when we talk about improving the accuracy, one thing we can do is we can come up with better models. Like we can basically pre-train uh, we train new models with high quality data set, or it can be even a larger model. For example, in the beginning, we had GPT-2, GPT 3.5, and those models, they have certain hallucination problems. They were not answering certain questions correctly. They were having a lot of issues. And then OpenAI, they went and they train a bigger, larger model with more data, like GPT-4, right? And then GPT-4 outperformed 3.5 with better answers. So like that, we can also try to train a larger model with more quality data. And the other option we have is, so we have foundational models. Foundational models are the models that already pre-trained. For example, GPT-4 is a foundational model. Llama is a foundational model. And we can take that foundational model and try to fine tune that. For fine tuning also can be like, improve in different aspects. For example, the most commonly used type of fine tuning is specific adaptation. This is where we try to fine tune model for a specific task. For example, if you want to do the sentiment analysis where we try to get uh, customer review or something and then try to assign a label saying this is a positive or this is a negative review, something like that. And in that case, we can try to give a supervised data set with set of reviews and their labels, sentiment labels, and try to fine tune a LLM for that task. And then that LLM can be used for only that task. Then we can't use it for general purpose stuff. The domain adaptation is where we try to give it more knowledge on a certain domain. For example, we can do it for the legal domain. We can get a lot of legal data, laws, those stuff, and then basically try to fine tune a LLM. Or there can be this other type of models, we call them SLMs, which are comparably smaller models. So those are smaller language models. So we can try to fine tune that with a lot of unsupervised or data, and then try to give more domain knowledge, domain expertise to that model. And the third one is the most important one, specifically if you are trying to do a startup or you want to experiment with LLMs, this is inference scaling. That means, and then this is a relatively new term. I'm not sure whether this term is widely adopted yet, but the idea is we try to improve the accuracy during the inference. So, which is a commonly, adopted uh, approach. And why this is important is because now you don't have to spend a lot of money, time on training models, cleaning data, preparing data, and basically that means like you are going for a huge commitment, right? Because once you train a model by spending a lot of money and time, now you have to use it somehow. You can't throw away that. But if you try with inference scaling, it's just doing some small tweaks during the inference time, and with that, even if you don't come up with something interesting or something useful, then still you can throw away that because that will require less time, less money, less, yeah. So like that, right? Less effort. So I want to focus now more on inference scaling. So if we go into inference scaling, again, there are multiple ways to do the inference scaling. So I have divided that into two main cases here. So one case is in-context learning. So in context learning, what we try to do is we try to give more knowledge to our Gen AI model, but not by training it, but adding more content to the prompt. So I think you all have tried ChatGPT, right? When you are trying ChatGPT, you ask different questions and then it will give you answers, right? So sometimes you want to do your assignments using ChatGPT. So then what do you do? So you will give the question and try to get answer, but it may not give you a correct answer because it doesn't know your syllabus. So then what you will do? You will submit some parts of from your syllabus, so it will know more about your syllabus, right? So like that, you can give more content to the prompt so that it will, it's not gonna remember that, it's not gonna learn that, but when answering that specific question or when performing that specific task, it can refer to that information and give you a response. And the other type of techniques, and in context learning, it solve the knowledge gap. But to solve the reasoning gap, we want prompt engineering techniques. So for example, we can do instruction prompting. That's where we can tell the model what to do. For example, you want to summarize data. So you will say summarize given text, and you will give the text and it will summarize it for you. Then you can say summarize the given text and make sure it won't include any political content. So like that, you can give more and more instructions and model will try to accommodate that, and then you will get a better answer that following certain reasoning process, right? And again, another thing you can do is few shot prompting. Few shot prompting can solve knowledge gap, also reasoning gap. In that case, you can show using examples to the model. This is the kind of response I need. For example, in the previous case also, you can give the full text and then give a summarized version and then let the model figure out what kind of output you need when you give the full text again. Oh, then you can do chain of thoughts. Again, I mean, these are like now 2, 3 years old patterns, but these are very critical because these are, I mean, still the base patterns that everybody work on, and these patterns are evolving. And for example, chain of thoughts have now tree of thoughts, and there are a lot of other different type of thought patterns, but chain of thoughts is the beginning of it. So it's very easy to understand in that case. So for example, think about a question that comes in your general knowledge paper where it will say there are 5 mangoes and you gave 3 to Nimal and 5 to Amal and like that. So there can be different questions, right? And to work on these questions, you will need to basically think about it step by step. You have to reason step by step. So these kind of problems, LLMs are not good at solving because if you ask LLM to solve such problem by giving that, even for example, the coding. So that's a very good example. So you can say, I want to create a, question answering application, or I want to basically create a something like that. Let's say hotel booking application website, and you can tell just that, and that, and then let it basically explore and give you the code generated. When you do that, there is a high likelihood you will not get ended up with what you actually want, and there will be certain syntax errors, compilation errors. There can be a lot of errors also, and the reason for that is because now it's not. I mean, the model is not reasoning like us. It's doing a generation, so it doesn't know that there are certain intermediate steps that it has to follow. Everything happen within the model architecture just to get some code generated. But if you say, okay, I need you to generate this code, but think about the libraries you need, think about the classes you need, what kind of classes, what kind of data models, what kind of a database, what kind of I mean, what kind of operations that this should be able to do. So think about those things step by step, and after you then start generate. I mean, do the coding. So then when you say like that, the model will start thinking, but when it is thinking, it will do it out loud. That means it will think by generating. So when it generate those steps, so it's again naturally following a certain completion process, and that will lead to a better reasoning, better generation. So the other thing is you can do role prompting, where you can ask the LLM to assume a certain behavior or a persona, like say you are a software engineer or you are a teacher. Like that, you can let the model or the LLM or GenAI model to assume a certain persona. And the other thing is you can constrain the LLM, like saying, okay, respond me with a JSON structure following this schema. So then it has to adhere to that schema and give you a response. And again, we are not telling like it will be 100% accurate, but it will try to accommodate your constraints to with a better accuracy rather than you are not telling anything about it, right? So that's the main idea. And also you can say reply with markdown content. So that's a common thing that we are using because we usually like to have markdown that is easy to render when you have text. Even ChatGPT, they generate everything in markdown. Yeah. So now those are like the basic inference scaling patterns. Now I want to go a little bit advanced patterns. So let's think about what are the advanced inference pattern. Now one thing is when we're talking about in-context learning, etc., with all like we can put all the data into the prompt and then ask questions, but there can be millions of documents and millions of data points, or even thousands of data points you can't or documents you can't put to the prompt. That's not going to be cost effective. That's going to induce a lot of latency, and that can even compromise the accuracy because now the Gen AI model or the LLM has to go through a lot of content. Or the other thing is you can have a diverse set of resources as well. We can't expect everything to be in document form, right? Or PDF. The things can be in APIs, databases, files, or maybe you want to do a web search and find the information, or it can be a real-time stream as well. So there can be different data sources as well. Now you have to feed all this data to the LLM, and this is during the inference time because we already established that we are not going to do training or fine tuning, and then basically get a accurate answer and with I mean reasonable latency also, right? So one way to achieve this is using retrieval augmented generation. So what does this mean? So in earlier case, when you do in-context learning, we said we are going to put all the information to the LLM or the prompt. For example, if you want to do a customer support bot, for example, in WSO2 case, we have a lot of, we have about 5, 6, 7 products. So all those products have different documentations, and that will include like hundred thousands or maybe even 10,000 documentation or the web pages. Now we have to put all those information to the LLM if we want to do a customer support agent, so that our agent or assistant can answer the questions accurately when the customers are facing different issues, right? So in such cases, how we can achieve that in a more efficient manner. So the idea of retrieval augmented generation is in such cases, when the customer is asking the question, we are not going to put all the information to the prompt. Instead of that, we are going to filter out what are the relevant documents that can possibly contain the answer for this question. And that subset of data is the only part we are going to put to the LLM for in-context learning. And to do that, there are different techniques. So the most commonly used technique is we use a uh, vector database. So I'll explain that also. If you look at this, now this is the full rack implementation. So for example, in our case, we have all the documentation in our product website. So what we can do is we can call the website, we can scrape all the content there, and then we have to clean out all the HTML, all the CSS style or the scripting tags, all the unrelated stuff because those are not important to give an answer, right? So that's just noise. So we just clean them. So that's the step A here. I hope you can see my cursor also. And then once we have cleaned it out, then what we can do is we have to basically so this is the information extraction, that's the cleaning part. So this is the retrieval, the crawling part. So we have crawl, then we are basically cleaning, and then we have to start breaking down this information into smaller pieces. And that can't be like a sentence, that can be like a small word. So we need to make sure that is larger enough to include a piece of information about a certain topic or a certain to do a certain operation in our product, something like that. Because if you divide it into smaller pieces, then it's very difficult to retrieve all of them at once. So that's the problem. And on the other hand, they can't be very large also. We can't have like 10 documents appended to create a single chunk. Then the whole purpose of doing this retrieval augment generation is go away, because we will then add a lot of unknown data to our prompt, right? When we have very large chunks that address different concerns. So we have to chunk it properly. So that's something you have to that's a decision you have to take based on your data, based on the structure of the data. That's a decision you have to take on at that time. And then you basically come up with the vector embeddings for that each chunk. The vector embedding, what that means is it's a vector representation for your chunk, for the text data in that chunk. So when you have these vector representations, it's very easy to now mathematically do operations to find out what are the similar chunks, what are the, I mean, those kind of operations, right? So these vector embeddings, they help us to later find out the similar chunks when we have a question. So we will basically put the document, the chunk, and the embeddings to the vector database. And vector database is basically capable of using the embeddings to index the chunks that we are putting into the database. Now, the data population part is completed. So this is just data preparation. So that's done. And then now users are coming and asking questions. So when users are coming and asking questions, we will first try to convert that question into an embedding, because now we need a vector representation of that question to basically match that with the vector representations we have for the chunks. This has to match, right? This question and the chunks. So that we do using these vector representations, this and this. So vector database, it is capable of basically, I mean, once you give this vector embedding, it's capable of basically retrieving k number of document chunks that are most similar to your question or the user's question. And once you get that, that means you have all the chunks that are relevant to the question. So you have to define what's the k number. Let's say it's 5. So that means you will always have 5 chunks that are most similar to the question. And then we can feed that chunks to the LLM, and also the question to the LLM, and then ask the LLM, by referring to the given information, answer my question. And then it will give an answer, and it will be really accurate if you actually have the content that could help to answer the question within these 5 chunks. Otherwise, again, it will hallucinate because we don't have the correct information. So that's what actually happened with this kind of this with the retrieval augmented generation. Yeah. So now we were talking about the retrieval augmented generation, and that basically help us to filter out the unrelated data when we are doing the in-context learning. So the other thing we can do to improve this situation, when we have very complex prompts, we can try to break them down into smaller manageable steps. For example, I can tell, okay, look at the given set of emails and basically find the important ones and reply only to the important emails. And when I say this to the LLM, what LLM will do is it will basically look at the emails. I mean, that means we will upload like 100 emails with the prompt as well, right? So it will go through the emails and try to basically pick some emails and then respond to that, because it is, I mean, this intermediate step that is required to filter the important emails are hidden now. It's not a explicit steps to the LLM. It's just hidden within the LLM's architecture, within the LLM's weights. So these kind of prompts are also not really helpful. So in that case, you have to decompose those prompts into multiple steps and that will help you to achieve a higher accuracy. And also, it will help you to build a scalable LLM, I mean the Gen AI architecture as well, because when you have these kind of very complex prompts, then it's very difficult for you to scale the architecture. You can't, I mean, for example, I will tell you why in the next slide, because I can show you how we can scale when we have decomposable steps. So in this case, now I have decomposed the previous uh, case. First, we will fetch all the emails, which doesn't require any LLM call. Then we will do a LLM call to go through the emails and select the important emails. And then once we have selected the important emails, we can basically again try to draft responses for the selected emails. So how we have done that in this diagram is we have first selected, I mean, we have got all the emails, and then we are feeding the emails to the LLM and say, basically filter out the important ones. And when we do that, we can basically do this as a batch processing. I mean, we don't have, if let's say we have like 100 emails, we don't need to put all the 100, right? That's gonna make the LLM's life miserable. So we can say, okay, first look at the 10 and then next 10, like that. We can basically do it as batches, right? And then for the first 10, we can select important emails. The second 10, we can pick up the important emails. And also, when you are picking up the important emails, we are not asking LLM to basically generate the email content. Again, that's a bad practice because you are generating unwanted stuff which we already know. We already know what we have in the email, right? So no point of generating that. We ask it to generate an email ID, some ID that we can map back to the email content. And when we have the IDs, we can basically go back to the set of emails and find the email content. And then again, for each email, we can try to draft the email body. We don't have to do it once for all the emails. We can do it for each email. So that's even better. Is it will give you more personalization for the response, and also it will be more accurate. I mean, otherwise, if you try to put all the emails and ask it to generate a response, it can even generate a single response or few responses only. So these things can happen. So with this kind of scalable architecture, by basically decomposing your complex task into a Gen AI workflow, you can get better accuracy, better scalability, and also it will basically help you to improve more aspects of your application. And there are certain frameworks that encourage this kind of task decomposition, like LangChain, LangGraph. I think you may have heard of those terms, but these are like Python frameworks and they are available in different languages as well. Yeah. So now we talk about like predefined workflows, right? Where we have a predefined flow of things that we want to do, and we basically decompose that and implemented that as a predefined workflow. And that's one type of problems that we want to solve. And there can be this other type of problems where we need to have a dynamic task execution. So in this case, the workflow is not predefined, it's dynamic. It is decided at the runtime. For example, let's say you want to do a hotel booking, or you want to basically use a certain travel agent and ask the travel agent to plan your travel plans, basically the flight, hotel, and based on a certain criteria, maybe you can give the budget. So these kind of things you can ask the travel agent to do, right? So in such cases, the this new pattern, this other pattern we call Gen AI agent, can be very helpful. In that pattern, what the agent does usually is it will basically decide what uh, tasks, I mean the subtask that it has to do first. So we call these subtasks as tools in the agent world, or the subtasks that are defined are tools. So this can be a function, this can be an API call. In this case, I mean, the example that I mentioned, it's going to be an API call, maybe the API call to the flight APIs to book the flight and check the availability of the flights, and also API call to the hotel API to check the availability of the rooms, and also maybe another call to the weather API, like that. There can be different API calls. And we first tell only these are the available set of tools to you. We are not going to define the workflow. We just tell you these are available set of tools. And then when we get the question, it will decide what tools we need to execute and also what are the inputs that we should give to the tool. And then it will execute the tool. And then once we execute the tool, we will have a tool output, right? So you can use that tool output and again do a decision process to see whether you need to execute more tools to complete the task or whether you can basically complete the task right now. So let's go through example as say. So for example, I mean the example is same. Like I want to do a travel planning. Say plan a 3-day trip to Tokyo, and my budget is $1,500. And when I say this, so what are the available tools to this agent now? The travel booking agent. So we have flight API, we have hotel API, we have weather API, and also we have web search. So these APIs are basically like this can be Emirates, this can be like hotel API for maybe it's the booking.com, or it can be hotel API for the Hilton hotels chain. I mean, it can be any hotel API. And we tell this to the agent. Now agent decide, okay, first I have to figure out what are the flights that I can use to go to the Tokyo. And also, if I travel these days, what are the hotels available for me to book? And also I have to make sure that my bookings are under this budget. So it will fetch the flight, the availability of the hotels, and also it will check the weather and the events, because now this trip has to be more enjoyable, right? If the weather is bad or there are no events happening, so that's not a good trip for you. It's not an enjoyable trip. So for that, you can use weather API, web search, and then it's gonna basically try to optimize itinerary for the given budget. And once it is done, so the agent can decide, okay, now I have all the information that is, or I have completed the task, so I can reply back to the user. And then it will return the complete plan with all the links that is required to do the booking and go ahead with that. So this is kind of the agent's process. So I can further try to explain if it is not clear. So this is a little bit of a different example. We are saying, okay, how much it would cost me to stay at this hotel for 2 nights. To get those kind of information, we have different tools. Like the API has different API endpoints, and we will define the tool definition within the tool to connect to the API endpoints. So the LLM will decide, okay, first I need to find the available hotels, and then I need to find the prices of the rooms from Hilton Hotel. Like that, it will basically decide what it has to do for each step based on the available information. Because once he get the list of hotels, he has to basically go and find because first he has to figure out what is the Hilton Hotel, and then only he can use that name and basically call this get hotel room info API to get the prices of the rooms. That's why this reasoning is happening. And once he have the prices, he say, okay, I now know the prices, so I can answer to the user. So this is very powerful pattern. This is kind of a pattern that is adopted for most of the cases right now in the world. And we will go to the next. This is like the evolution of that pattern, where in that case we had a single agent. Right now in this case, we are telling, okay, you can decompose your task into multiple agents as well when the task is even bigger. For example, if you want to do a code generation and for a given set of requirements, and this is not just a like single small code segment or a script, this is like a full project. In that case, we have a code generate agent, which has a lot of tools to generate the code, and it will generate the code and hand over that code to the execution agent, and execution agent try to run that code. There can be a compilation error. So when we have a compilation error, it will be handed over to the code debugging agent, and debugging agent will look at the compilation error and basically also the code and try to come up with the root cause analysis report where we have the cause of that error, and then basically go back to the code generator and agent and say, okay, these are the issues that I found, basically go and fix it. and then code generator agent will again generate a code, and execution agent will execute it, and execution test will pass, and then it will be handed over to the testing agent, which will basically do the runtime testing, like actually invoke in the code or execute in the code to see like whether it's producing accurate results. So like that, there can be multiple agents, a crew of agent or a group of agent that are collaborating and basically trying to accomplish more complex tasks. And there are a lot of frameworks for that, like most common most famous frameworks are the Crew AI, AutoGen, those kind of frameworks. You can try it out. It's a very interesting pattern, and it's like very powerful thing that we are seeing emerging right now. And again, another thing that we can do to improve the accuracy, and this is the last thing, so that using the same LLM or a different LLM to double check their outputs. And this is really interesting. Like, for example, if you do that with a human, this won't work, right? So let's say you ask me a question and I give answer. If you try to double check with me, I will give you the same answer. But with LLMs, it's a bit different because LLM doesn't have the answer it gave earlier. LLM doesn't have its state. So every time you ask a question, LLM can give you a different answer as well. But in this case, you are doing a slightly different task as well. You are not asking the same question again. You are telling the LLM, go back and review your answer. And when you do that, we have found it is basically reviewing it correctly for most of the cases. And this is a really good pattern. With this, you can again use LLMs more efficiently. And this is a pattern that is used to evaluate the LLM as well. So you can look up the term like model as a judge. So you can use the LLM as a judge as well. So we can basically evaluate the LLM using a LLM. And it can be the same LLM as well. It doesn't have to be a different LLM. Okay, now we talk about like a lot of stuff that we can help, that can help you to build accurate, reliable GenAI applications. And that's again part of the scalability of the GenAI applications when it comes to accuracy aspects. But now let's go into the scalability of the performance aspects. So yes, LLM performance is a problem actually because LLM models are inherently slow during the inference because they are very large models. They do a lot of computations during the inference. And again, inference is scaling techniques that we discussed earlier, like the RAG or the agents or task decomposition, also in context learning, prompt engineering, all those things will increase the prompt size and also introduce more LLM calls, multiple LLM calls, which will actually beneficial for the accuracy, but not so beneficial for the latency aspect. I assume you know the term latency. Latency means the time taken to give you the response when you basically use a certain service. For example, if you try to ask a question in ChatGPT, if it take like 10 seconds to respond to you back, that's the latency of that service. And again, the another orthogonal problem is like when you have larger prompts, you will have to pay more. So that's again orthogonal problem, which we are not going to consider in this scenario, but I just mentioned it so you will know. Yeah. So this is a question that somebody asked from ChatGPT, and it's still analyzing. It has taken like 40 seconds, but it's still analyzing. So this is a kind of a bad user experience. Actually, in pre-Gen AI era, before Gen AI models, even 10 seconds or 5 seconds was a really bad experience. But now we are more patience, more tolerable with this kind of latency. But 40 seconds is not actually a good response time. So now think how we can improve this situation. And keeping that in mind, let me introduce you this another concept. Maybe you are familiar with that, but let me introduce that in anyway. So this called this synchronous versus asynchronous processing. So what this concept tell you is, if you have something synchronous, in a synchronous design or a synchronous processing, so after each request, the client will wait for the server's response to send the second request. For example, if you ask a question from ChatGPT, it will I mean, you can't answer the second question until it responds you back. And in asynchronous processing, when you ask a question, or when the client send a question to the server or a query to the server or the request, the more generic term, the client won't wait till the server respond back. It will go and proceed with the second response as well. So it will keep sending request to the server, and when server finish something, it will respond back to the client. And how this is implemented is, it's a very interesting thing. You can look it up, how usually these things are implemented. But I will give you a like high level idea. You can have an event loop. So basically, your event loop will basically, the client will send request, then the event loop will do a round robin kind of rotation and give access to the second client. So the second request, and that will be sent, and it will then check whether we have received the response for the first request. If not, it's proceed to the second request. Like that, it will keep checking until we get a response. And this is kind of a loop that iterate through all the requests. Why is it important now? This is very important to the Gen AI domain because Gen AI models are very slow, as I said earlier, and these are like APIs. That means it's like external server calls. So now what we can make use of is this async design to do the model invocations. So instead of like trying to basically do a synchronous traditional design or the programming process, you can use asynchronous model, and with that you can basically call the Gen AI API. So the Gen AI APIs, all the requests that are coming to the client will be sent to the Gen AI API, and the ones that are completed by the Gen AI API will be returned back, and there won't be any locked process or a process that are waiting. So by other requests, right? So that's the high level idea. And this will give you a very high concurrent application. So this is very important. And the way to implement this is using async IO or fast framework like fast API. Async IO is basically to get implement it in a raw form, like with the clients and everything. But fast API is a framework you can do asynchronous services by yourself. And the other way you can use this async type of design, this is when, for example, you have like certain complex tasks, like you want to do a certain report generation, or you want to generate an image with ChatGPT. In those kind of cases, the real-time response is not that critical, and also it will take like a lot of time to do that also. So instead of like asking user to wait, you can tell the user, okay, I will do this and notify you later once it is done. And this is very important because this won't block the user experience. This won't block the UI. So users can continue to do their stuff until that task is done without waiting for that. So I can show you example. So when I ask ChatGPT to generate a certain image, it is not asking me to wait anymore. Like in previously, it was asking me to wait till it's generated, but now it's saying, okay, I will generate it for you and basically notify you when it is ready. So this is again a pattern that you can use to basically, mitigate the issues with the higher latency with Gen AI models and or Gen AI application. And there are a couple of other techniques also. I will go through them quickly. So this will help you to basically build uh, high performing, not high performing, we can't say high performing actually, this, but improve the performance of your Gen AI applications. And these are very important if you want to do a real-time experience, like you want to respond back immediately. For example, you can parallelize the LLM calls, and this can be done when you have like independent set of subtasks that can be done. For example, in the previous agent case, I said we need to find out the available set of flights, available set of hotels, And those two we can parallelize. We can say, okay, find the flights, find the hotels parallelly. We don't have to do it sequentially. Or we need to find about the available events and the weather conditions. Those also we can parallelize. We don't have to wait. We can say, okay, find the weather condition and also find the events. And once both the okay, that's again not actually a LLM call. So sorry. So that's maybe a not a really good example for this scenario. But a good example would be like when you have a set of tasks, for example, in the code generation case. So we want to generate the code. So now when you generate the code, you need to have multiple classes also, right? So you can say generate class A, class B parallelly. You don't have to wait till you are generating class A, so you can generate the class B, right? So you can do those kind of parallelization. When you are generating report also, you can generate the different components of the report parallelly. So this is again an important pattern, and this is different from asynchronous processing. Asynchronous processing is not a parallelization. It is making use of the same process but more efficiently. So then the another thing you can do, I think this is something very common, you might have seen. You've seen this server sent events like SSC. This is what ChatGPT does when you ask a question. Now you don't have to wait till you get the full answer. I mean, not you. The ChatGPT doesn't wait till it get the full answer to show that to the user. Like, so when you ask the question, when the first token is generated, it's going to start streaming that answer back to the user. So this is very useful. We are also using these kind of approaches to hide the higher latency with the LLMs. This is not actually removing the latency, or minimizing the latency. This just hide the fact that it takes longer to generate the full answer. And anyway, if you generate the full answer at once, still user will take time to read that, right? So this is a good experience for chatbots. And the other thing you can use is semantic caching. So that means like when you get similar prompts or same prompt, you don't have to ask that question again from the LLM, right? What you can do is you can have a caching mechanism. We usually call it semantic caching because you do a similarity based caching, like you look at your prompt and you look at whether there has been a similar prompt before. And based on that, you can get the answer from the cache without calling the LLM. So this can also improve the inference latency. Another problem with LLMs, now when you're using these LLM APIs, they have a certain throttling based on the token usage or number of API calls. Because they are like shared resources, right? So you are not the only person who are using it. So one thing you can do is you can create multiple LLM services. For example, this you can do with Azure OpenAI. And each LLM service will have its dedicated throttling limit. So for example, let's say each LLM service will let you use it with the rate of maybe 1,000 tokens per second. Now you can basically have a load balancer in between. And then let's say we have 3 LLM accounts, we can use 3 LLM accounts and balance the load get into your AI application between all those 3 LLM accounts. And this is very important because if you have a high concurrency or high throughput application, and when you are getting a lot of requests from the user, if the LLM is throttling, then you will get a very bad latency because it's gonna basically block the user's request until you will get a new quota for the next second. So, and this is the best way to avoid, and also like economical way to avoid those kind of situations. Sure. So I think that concludes what I wanted to cover today. So first thing is like Gen AI, it has unlocked rapid AI development, which is specifically beneficial for startups. So you can do a lot of stuff right now, and also The other thing is, although it is very convenient, hallucination is the core challenge, and that you can mitigate through in-context learning, prompt engineering, or task decomposition through retrieval augmented generation, or agents or multi-agents, right? So there are a bunch of things that we discuss. And then again, Gen models, they have high latency. This is because of the, I mean, inference is not that simple, right? So inference is heavy, and also to improve the hallucination situation, so you will add a lot of long prompts, a lot of data to the prompt, and also you will include multiple LLM calls. So this will introduce high latency to your GenAI application as well. And then you have certain ways to scale the performance also to improve the user experience by uh, mitigating the issues with the latency, right? So those are the things that we discussed today. Yeah. Mhm. Mhm.
We have
Do you
now
have,
come
sorry.
We have now come to the Q&A segment of our session. If you have any doubts or thoughts you would like to share, we encourage you to submit them through Slido, or you can simply scan the QR code on the screen or use the link provided in the Zoom chat box to send in your questions. Let's now open the floor for an engagement discussion.
Okay, if we have no questions, it seems like everything is understood, or okay, we have questions. Okay, which agentic framework best for production? It depends on the programming language you want to use, and also the type of agent you want to build. For example, if you want to do a simple agent, maybe you can use a LangChain, LangGraph, those kind of frameworks. And also if you want to use like .NET kind of a language, you can go for semantic kernel kind of a agentic framework. And also if you want to build multi-agent applications, then you have Crew AI, Autogen, and again they also have different opinionated differences. For example, Crew AI, it's always about task execution. So you can give a task to your crew of agents, and it will basically execute that task for you. But if you come to the auto chain, it's more about more chat experiences, or more group of groups trying to do certain stuff like group chats, etc. So there are different variations. So it's very difficult to tell what is the best framework, but the most popular ones are semantic kernel, autogen, crew AI, line graph, line chain. Those are the most commonly used ones, right? Can agents in reinforcement learning be associated with LLM agents? Okay, so agent is a concept that was there from the beginning, and now agent means is kind of an autonomous entity that can basically what do you call it, engage with the environment and execute certain tasks until, I mean, achieve a certain set of goals. So that's what the agent is. So it can interact with the environment and achieve a set of goals. And whether you implement that with reinforcement learning or LLMs, it's again the concept is same, but the thing now is then when you use reinforcement learning, then the agent has a different behavior. It try to, I mean, the model within the agent try to learn from that uh, environment or the actions that's performing. In the LLM case, it is also learning, but it's not gonna train the model. It's not gonna change the weight of the model. It's gonna add that observations to the prompt, and it use its the model's in context learning property to basically adjust the thought process. So these are the difference. This is the main difference. So right now, I haven't seen a case where we will try to do a reinforcement learning kind of a situation where we actually try to train the model's weights. Uh, Only situation I have seen is the way we use right now is the in context learning kind of a adjustment. So I think that clarified your question, right? So if not, I think you can basically ask it later from me to a different chat. And so using Grok, can we use like yeah, Grok is again is not a framework, right? You're talking about the Grok, this LLM hosting platform, right? So you can basically use any model hosted with Grok. I mean, RAG is nothing magical. You don't even need a framework to implement RAG. It just you fetch some information using vector database by giving the question. By giving the question, you fetch the information from the vector database and then put that to the prompt. That's it. So it's not nothing magical. Yes, so you can do it with Grok or any other vendor as well. I don't understand like how I can tell example wrapping from Grok. It's gonna be similar set of examples. Maybe I don't get the question. What's the next big trend in AI? Okay, right now it's the multi-agents. So that's where the trend is going, and basically trying to get agents that are that can impersonate users or act on behalf of users. So think of a scenario now. Usually we have seen these AI systems or the agents as our slaves, right? So they are basically we give the task and they just do it. But think of a scenario you have a colleague or you have a lecturer that is an agent. So this way I think it's going, but we don't know. I mean, we can't tell right now, but this is the direction is going. So you will have an agent lecturer and he knows about the syllabus, he knows about the content, he knows how to teach you, he will teach you, or he or she. Yeah, so that's the next big thing, I guess. When deploying LLMs, yeah, security and ethical concerns. Okay, basically security is like people doing jailbreaking, prompt injection, or misusing your LLM. So again, this is a different topic. I mean, if you want to discuss about this, we need like more 30 minutes more. So I think I will try to give a short answer. There are a lot of security concerns like that. So somebody will try to misuse your LLM, or somebody will try to uh, basically use the LLM to misuse your other APIs, because now LLM can make decisions to access what are the available set of information, right? So now somebody can try to access a set of unauthorized information through your LLM. For example, if you do a SQL injection, sorry, SQL query generation, LLM can generate harmful queries. So that's a problem. And the ethical concerns, that's basically, I mean, there are a lot of ethical concerns. Most of the concerns are basically based on like it can generate harmful stuff. It can generate a certain, I mean, unacceptable content. So that's one of the areas, and also it can be biased because these are machine learning models. Like human, they are also biased to the data that they have seen. So that's again a serious concern with LLMs. But again, so you can solve most of those problems with different layers. So that's how you will do. You can have guardrails. So that's again a different topics. So there are AI gateways to add guardrails to govern your LLM. So you can do a lot of stuff. Okay, I will answer one more question because I had to leave. So I will answer the one with the what. If people stop doing this, they say the new things won't be created right now. Like for new data. Yeah, I think, I mean, I have seen a lot of debates. So that can be a problem. And also the data corruption, because now we have a lot of AI generated content all over the internet. So that's a huge problem because you you are now training LLMs with the data generated by LLMs, and they can be factually incorrect. I mean, these LLM generated content, most of the time they are misleading, they are incorrect, right? People will try to spam the internet. So yes, so you'll get more incorrect LLMs. Maybe the history will change when we train more and more LLMs. The things that LLM knows will change. So yes, there can be a lot of things happening, and the future, I'm not sure like what will happen, but yes, data is a big problem, and also data will come with other forms as well, right? So it's not gonna be just text. It's gonna be, for example, this can make data creation more efficient as well, because now we can create more data more efficiently because we have the LLMs. So there is that benefit as well, because right now, if you want to write an essay, you can give the points and then ask the LLM to do the polishing and everything, right? So there are that aspect as well. And also there can be new type of data where you can have this, I mean, self-driving cars, which basically collect the data from all the environment. So like that, you'll get more new type of data with new systems coming in, and then maybe it will be solved with those data. We don't know. So you have to wait and see. Yeah, so I think I can't take other questions because I have another call, so I have to leave now. Maybe what we can do is you can send the questions to my email and I will try to answer them. That's good enough, right?
Thank you for your thoughtful questions and engaging discussion. Thank you so much, sir, for sharing your valuable insights and expertise with us today. As a token of sincere appreciation, we would now like to present a virtual memento on behalf of our team. We kindly invite you to accept this gesture as a small symbol of our gratitude for taking this time to engage and inspire us this evening. It is time to thank our esteemed partners who give their constant support throughout CodeSprint X. Their contributions have been instrumental in bringing this event to life, providing us knowledge and support. Platinum Partner, Digital Team. Digital Team Private Limited offers smart offshoring solutions by building dedicated IT teams in Sri Lanka tailored to your needs. Silver Partner, Creative Software. Creative Software Private Limited leverages 20+ years of expertise to build dedicated software teams and deliver projects based on solutions that enhance agility and profitability for global clients. Emerging partners, CubeMark Labs. CubeMark Labs as a Sri Lankan IT service provider specializing in delivering innovative, timely, and cost-effective technology solutions. Traditional Gem Mine. Traditional Gem Mine Private Limited specializes in premium handcrafted jewelry intricate designs for every occasion. Deluxe's Infotech. Deluxe's Infotech delivers tailored future-ready digital solutions in web, mobile, AI, and blockchain to help businesses thrive in the digital era. Knowledge Partners, Fortude. Fortude is a global digital services company delivering end-to-end ERP solutions and enterprise technologies across data, cloud, automation with a presence in 6 countries. InfoWaves. InfoWaves deliver digital transformation solutions along with long-term support and maintenance for business of all sizes. Anyverse. Anyverse, founded in 2019, has rapidly grown into global tech leader offering end-to-end digital solutions across software, AI, blockchain, and ERP services with a presence in more than 8 countries. Vertisa. Vertisa is a global provider of digital strategy, engineering, and IT services, helping Global 2000 companies drive innovation and unlock value at speed. Banking partner HNB, Hatton National PLC is a leading Sri Lankan private bank with extensive reach, driving economic growth through innovative customer-focused banking solutions. startup ecosystem partner LeadGen. IIT LeadGen Accelerator empowers students and innovators to transform ideas into ventures through a collaborative, innovation-driven ecosystem. Co-working space partner CoLabs, designed to inspire creativity. CoLabs offers modern, convenient meeting spaces for founders, freelancers, teams, and professionals. Food partner Prima Kothmi, home to the popular Prima Kothmi brand, Ceylon Agro Industries Limited (CAI), is a leading Sri Lankan food manufacturer specializing in wheat-based dairy and poultry products, supporting the local food industry and agriculture. Beverage partner Kotmale, established in 1991, Kotmale Private Limited has grown into one of Sri Lanka's most trusted dairy brands, offering fresh, high-quality milk, dairy products sourced from local farmers. Print media partner Ceylon Today. Ceylon Today is an English-language Sri Lankan daily newspaper published by Ceylon Newspaper Limited, committed to delivering insightful and reliable journalism across a broad spectrum of topics. As a media partner, their support enhances the visibility of our event, ensuring impactful coverage that reaches a diverse and engaged readership. Online event partners, Hackathons.lk. Hackathons.lk is a leading platform in Sri Lanka's tech ecosystem, committed to fostering innovation through competitive coding and problem solving. As an online event partner, they bring together a vibrant community of developers, offering tools and visibility that elevate the hackathon experience. HackSL. HackSL empowers the next generation to tech talent by creating engaging, accessible opportunities for collaboration and growth. As an online event partner, they help bridge the gap between aspiring innovators and real-world challenges through well-curated digital platforms. Photography partner, Dayglare. Dayglare is a creative photography partner dedicated to capturing the essence of every moment with a keen eye for detail and a passion for visual storytelling. They ensure that every highlight of the event is preserved with clarity and style, turning fleeting moments into lasting moments. Before we officially wrap up, we would love to capture this moment with all of you. We kindly request everyone to turn on their cameras so we can take a quick virtual group photo to commemorate today's event. Thank you, everyone. As we come to the end of Prototype Workshop 2, I would like to sincerely thank each of you for your active participation and enthusiasm throughout the session. A heartfelt thank you to our guest speaker, Mr. Nadheesh Jihan, for sharing his deep expertise and practical insights on scaling AI agent. Your session has certainly inspired us to think beyond the conventional and innovate with confidence. We hope today's session has equipped you with valuable knowledge and sparked new ideas for your future projects. Follow us on our social media to keep an eye on upcoming events, and we look forward to welcoming you to our upcoming workshops. Until next time, stay inspired, keep exploring, and never stop building. Thank you once again, and have a good night.
Ceylon Today, Truth Uncropped.
The pace of change in today's digital environment is set to always. And you don't want to just keep pace. You want to leap ahead. A partner like Virtusa can help you navigate the digital landscape of today and tomorrow. We see a problem as an opportunity to get better, to get faster, to get more efficient. We combine logic, creativity, and curiosity to solve, build, and create. Down through your tech stack or up in the cloud. Engineering first means when you're faced with a wall, we'll build you a door. Helping you reduce your development time, lower your testing costs, while raising your product quality. That's transforming business at scale and speed. Whatever your business challenge may be, Virtusa can help engineer a solution. Because business transformation that lasts starts with engineering first.
Are you ready to see how AI can transform lives? At Delexis, we're leading innovation in AI, mobile, and blockchain technologies, crafting a future where technology truly empowers humanity. We're not just building algorithms, we're building a better world. Delexis is dedicated to using AI to solve pressing global challenges and uplift communities. Be part of our journey. Explore Delexis, contribute to our mission, and let's build an inspiring future together.
I can't be fixed. 1, 2, 3, your attention's all I need. 1, 2, 3, I don't know who else to be. 4, 5, 6, like they say I can't be fixed. 1, 2, 3, your attention's all I need. 4, 5, 6, don't let it slip.